So now I'd like to bring up Erik Lagerway, and who has got the task of leading both the ORTC community group and the WebRTC working group incorporation of the object model. So take it away, Erik.
Thanks, Bernard. Smart guy. So how many of you are building for not just browser-based desktop applications, but native desktop applications in the crowd here? If you could just show me a show of hands. Yeah, so apparently 40% of all desktop applications are based on Windows. It was a bit of a surprise for me, but very happy to hear that. And one of the other, this is the clicker, right? Nope. One of the other surprises that you may come to as part of understanding WebRTC is WebRTC was initially designed to eliminate plugins and third-party software for browsers. That was kind of the impetus behind the technology back in 2011, spring of 2011, in the IETF meeting in Prague. And what's actually happened here is kind of the opposite. So now we have this mass explosion of mobile growth behind WebRTC, and that's kind of where you see a lot of this new growth coming from for WebRTC applications. The desktop is still valid and it's still there, but the mobile growth is huge. So we've heard a lot about ORTC APIs and Edge and what you can do with them and how you can leverage those to build some very cool real-time communications applications. But what happens when you want to go build something that is more native, that is more WinRT specific? And that's exactly what the ORTC library was built to do. So this WebRTC stuff is really easy, right? You just saw how easy it was for Bernard to build these applications. As we know, or some of you may know, one more show of hands. How many of you have tried to implement or build an application with real-time communications today? How many of you? So probably about 10 at the most. Yeah. So it's not really as straightforward as we'd like it to be, but and as you can see here, I've kind of listed some basic obstacles that make it a little tough. So don't panic. We're here to save the day. It's a glorious day in San Francisco. We're going to help you. So the ORTC library is a very simple library to implement. It comes by way of a NuGet package, and also it's MIT open source on GitHub. So you can use this library to do some pretty interesting things with your native applications for WinRT. And we do support iOS and Android. Those wrappers aren't quite ready yet for consumption, but they're coming soon. So first step is to go to openpeer/peercc.git, open your Visual Studio Workspace, run the PeerCC server. If you don't want to build it yourself, you can get a hold of us, and we'll give you a precompiled version of that. Step 4, run, then choose a peer. The sample app is pretty straightforward. And this sample app is built with, it's called the PeerCC sample, or Peer Connection sample, and it actually incorporates SDP in there. So this isn't pure ORTC type of sample. There's another sample coming that will be exclusively ORTC specific, but this will get you running. So what does this do for you? Well, we spent 3 years and about $2 million in development and building this library. Again, it's open source. It's available for WinRT. It was kind of purpose-built for the Windows platforms. And it will be wrapped for iOS and Android in the coming weeks. It's compatible with 1.0 enabled browsers and applications. And we do all the heavy lifting for you in terms of syncing with the upstream repos. It's friendly for ORTC on Edge, so it'll be interoperable with ORTC's applications written on the Edge APIs. It's more mobile-centric, so if you're looking for something that is very performant in a mobile deployment, this is kind of the best bet going for OpenRTC type of mobile applications. So what are some of the advanced capabilities of this library? As I mentioned before, it's a very mobile-centric library. So one of the things that we find when we're using WebRTC today is we go from a Wi-Fi network to an LTE network, back to a Wi-Fi network, the background application, the foreground application, the background, there's a whole bunch of things going on there. And the current stack doesn't really handle that well in the libraries that are out there today. The ORTC library was kind of purpose-built for these types of network transitions. So it handles what we call mobile roaming in a more seamless fashion. Fast network failover, so when you combine this with a really resilient network from a media relay perspective, you get some pretty interesting things that happen on a fast network failover. So if I've got a bad leg on one side of the network and I want to be able to replace that with something else, this library will actually allow you to do that a lot more seamlessly. And again, optimized for mobile, so battery and footprint friendly, supports simulcasting for send and receive streams, supports data channel, and the one thing that was being talked about earlier today was advanced diagnostics by way of Windows Performance Analyzer and Recorder. We've actually done some pretty heavy integration with those tools, and you can actually use the library to do some pretty interesting diagnostic detail when we do some, when we're running calls and we're running into a network issue or running into a system issue, we actually have inbuilt EPW or ETW and Recorder Analyzer plugins available for this library as well. It's not just for talking heads. So when we talk about WebRTC and ORTC, a lot of the time people immediately think about Skype, right? Like Skype-like features. It's not just for that. So there's a lot of things that we can do with this that aren't just related to video conferencing. The data channel itself is very useful. It could be a background data channel available for gamers. By the way, just a fun fact, the ORTC library is enumerating on Xbox today, and we expect to be shipping something for Xbox in the next, I'd say probably 3-4 weeks. So you can do some interesting things in the gaming genre. We can do some interesting things with IoT. If you take consideration of IoT and you think about some of the monitoring capabilities in that regard and real-time communication, you can, the wheels start turning. Advanced scenarios, advanced simulcasts, as mentioned before, the mobile handling of foreground background applications, and sending media without signaling and media and call forking. And call forking is just another way of saying I can send my call to this endpoint, I can send my call to that endpoint, and I can pick up either one of them. It really doesn't matter to the library. So the beautiful thing is we have worked tirelessly on this for the last 3 years, and we're happy to announce today that's available today. You can download it via NuGet, so you just search Hook Flash in NuGet, and you'll find it. If it's not available this very moment, give it another 15-20 minutes. It was only uploaded about a half an hour ago. The GitHub source code is also available. I'm going to save you the grief of not putting the link in here. If you guys want to get access to this stuff, just come up and see us. We're on the 3rd floor, and we're happy to give you some interesting diagnostic demos as well in diagnosing real-time communication network trauma. We're also announcing a new network service in relation to this library. So as I was mentioning, when you want to get your media off of a really nasty firewall, you want to get over that firewall, you kind of need a media relay and a NAT traversal service to help you do that. And that's what we're also announcing today. It's called Relay First. So we're here to help you guys implement these tools. We're here to talk to you about some of the projects that you're working on. We're on the 3rd floor. Bernard and I will be up there shortly to answer any questions that you may have. If you need any more information on Hook Flash and some of the applications, some of the information on the library and the Relay First network, you can check out hookflash.com, or like I said, come see us upstairs. Thank you.